Hi everyone, welcome to Coach Calculus channel. In this channel, we are responsible for making mathematics easier for you. So, in this particular video, we'll be dealing with factorizing the difference of two squares. And this is part 2 with common factors or expressions. You can see the questions we have before us here. If you think these questions might be too complex for you, I've done a video on the part 1 for on easier ones that you can cope with easily. So you can search Coach Calculus channel and look for the video there. And for this particular one, without if you are new to this channel, do well to subscribe to the channel so that when next you are looking for a solution to your mathematical problems, you can easily locate the channel again. And without wasting much of our time, let's dive in. Solution. Then the solution number 1. For the number 1, we have 2x square. For the number 1, we have 2x square minus 50y square minus 50y square. So this is the expression given to us. The first step here is to bring out the common factors. Now, here we have 2 here, and we can also remove 2 from this side. That is 50 divided by 2. So bring out the common factor. This is 2, then open brackets. If we remove 2 from here will remain x square. 50 divided by 2 here will remain 25y square. So this is what we have in the bracket. And then this x square is a perfect square. But this one now we can break it down as 25y square is equal to 5y bracket square. So now let's write this expression using this one for this one now. So we now have x square minus this expression now, open bracket, 5y square. Now I've gotten to this form, and this formula will be very much helpful to us. A square minus b square is equal to, open bracket, a minus b, open another bracket again, a plus b. So using this formula, we can now break down this expression that I wrote here, which is equal to, open bracket, x minus 5y, close bracket, now open another one, x plus 5y. So our final answer will be, remember we brought out 2 here as a common factor, so it has to be with this one that we just simplified. So our final answer is 2, open bracket, this expression now, which is 2, open bracket, x minus 5y, close bracket, open another bracket, x plus 5y. So this is the answer. This is the answer to number 1. For the number 2, we have 1 minus, open bracket, x minus y, close bracket, square. So the first step here is to identify this one as a perfect square, which can be written as 1 square, and then we also have this one in bracket squared already. So I'm going to rewrite these expressions in difference of two form, which will be 1 square minus open bracket x minus y close bracket square. So, the using that formula, we now have that this expression 1 square minus open bracket x minus 1 square is equal to open bracket 1 minus x. This one is in another bracket, 1 minus y in bracket, and then the bracket larger bracket, and then open another bracket, 1 plus open bracket x plus minus rather x minus y x minus y x minus y. Then simplifying, have open bracket 1 minus x. This minus will affect this one, turn plus y plus y. Then open the other bracket, 1 plus x 1 plus x. This plus now will affect the minus, I say, so this one will turn minus y. So this is the answer to number 2, just in bracket. And then the number 3 question, we have 45 a raised to power 5 minus 20 a raised to power 3. So the first step here is to factor out. Bring out the common factor. 5 raised to power 3 can go in both of them. 5a raised to power 3 can go in both of them. So I'm going to bring out 5a raised to power 3. Now this place, now if you remove 5a raised to power 3, we'll be left with 9a raised to power 2, 9a square. If we remove 5a raised to power 3 from this place, a will be removed completely, and then 20 divided by 5, that is 4. So minus 4. Now we've brought out the common factor. The next step now is to break down these ones. This particular one now, 9a square. 9a square can be written as 3a square. Y and 4 can be written as 2 raised to power 2. So the expression now is, we now have 5a raised to power 3 open bracket these two expressions now in place of these ones. So we now have 3a square minus 2 raised to power 2. So this is difference of 2. So what we are going to do, I want to resolve this one in the bracket first of all. So I have 3a square 3a square minus 2 raised to power 2 is equal to open bracket 3a square minus 2. There's no need for square again. 3a minus 2, open another bracket 3a plus 2. So our final answer now will be bringing this common factor outside. The final answer will be 5a raised to power 3, 5a raised to power 3, open bracket 3a minus 2, open another bracket 3a plus 2. So this is the final answer to number 3. For the number 4 we have 2p square minus 8, open bracket p plus 2 square. So this is the equation. So the first step here is to factor out this. 2 is a common factor here. So I'm going to write 2 square bracket, then square minus 4, open bracket p plus 2 square bracket square. So with this, I've bring out the common factors here. So the next thing is to recognize the perfect squares. P square is a perfect square. Perfect squares are p square and 4, open bracket p plus 2 square, which is equal to open bracket square, open bracket, then 2, open bracket p plus 2, close the bracket, and then the square bracket square. So this is one of the perfect square and this is the other perfect square. Now applying the formula, we have that p square minus this particular one here minus this one here, that is 2, open bracket p plus 2 square is equal to open bracket p minus this value here, this value which is 2 plus 2, and then another bracket open again, and open another bracket again, p plus this function 2, open bracket p plus 2, and then close the bracket. So the next step here is to simplify this particular ones in the bracket. For the first one, we have open bracket p minus this minus 2p, then minus 2p times this nice minus 4, then open the other bracket p plus 2p this times this plus 4p. So come down again, then p minus 2p, that is minus p minus 2p, that is minus p minus 4, minus p minus 4, and then open bracket. The other, this one, p plus 2p, that is 3p, 3p, that is 3p plus 4, 3p plus, I think there is an error here. We did 2 times 2, which is 4, not 4p. Not 4p, it's just 4 plus 4. So this is answer I got while simplifying this. And then our final answer will be these two that we brought out as common factor here. We are going to write it here. 2 open bracket, this one minus p minus 4 open bracket 3p plus 4, 3p plus 4. So this is the answer to number 4 question. So finally the number 5 question. The number 5 question, open bracket y minus 1 close bracket y square minus 9z square, 9z square. So this one now is identified as a perfect square, but this one now we are going to break it down again as, so this expression now can be rewritten as y minus 1 square minus this particular one now can be broken down to 3z square. So now we now have the expressions in difference of two squares. So applying that formula, this will be equal to open bracket y minus open bracket y minus 1 minus, remember this is a larger function now. This particular one is inside this bigger parenthesis, and then y minus 1 minus this value 3z, and then you close it, then you open another one, then open in bracket this value here y minus 1, close it, then plus 3z, and then that is equal to, now I want to break these brackets, the smaller brackets I want to break them. So we have y minus 1 minus 3z, y minus 1 minus 3z, then open the other bracket, we have y minus 1 plus 3z plus 3z. So this is the answer to number 5. And we have come to the end of this video. Thank you very much for watching. And mind you, if you are new to this channel, do well to like, subscribe, and turn on the notification bell so that when next you are looking for a solution to your mathematical problems, you can easily locate this channel again. And if you think these ones are too difficult for you or hard for you to cope with, you can go and search for the easier one, part 1. And also, if you think this one is too easier for you, are looking for more complex ones, you can also search for the part 3 for the more complex ones. Thank you very much for watching.